for letting me know, really appreciate it. Right, the Southside Hereford Student University Challenge is interdisciplinary, cross-university, and a team challenge. It's to design, engineer, specify, and cost a community building from timber to passive house standards. You have a budget of 1.6 million and a space requirement of around 800 square meters. And we've been assured by people who build to passive house standards that that is imminently possible. The building will be one building, one physical building on the boundary of 2 fields, and it's a greenfield site. It's formerly park and farmland, and please ignore the design or the sketch. It is completely up to you how you design it. But we have got a brief from the clients who want it to sit lightly on the planet, be built from timber and to passive house standards. If you've been following us, you will know we have a YouTube channel where all these webinars are recorded. The university design page is on the TRADA website, and you book via Eventbrite, which is you know, why you're all here. We could not, tonight's you'll hear from our sponsors, and we could not put this challenge on without our sponsors' support. So I just want to say a huge thank you. You heard from Transforming Timber, our major sponsor, last week. PH15 spoke in an earlier webinar, and tonight you'll hear from Accoya, PEFC, Stora, Enso, the Timber Decking and Cladding Association, Wood for Good. And we're also supported by Rotherglass, the AECB, Design PH, Trimble, and the UFI RockTech Trust. And tonight we're going to hear from Alun Watkins to start with, who is CEO of PEFC. Sarah Virgo from Wood for Good unfortunately can't make it, but she's recorded a video about all the resources. Janet, who Sycamore from the Timber Decking and Cladding Association, I know has attended many webinars that we've been in previously. Mike Lewis is new to us from Axis, and we'll talk about Accoya. And Mila is, again, it's great to see her presenting. Last year she presented for Edinburgh Napier University, and this year she's with Stora Enso. So I'm going to stop screen sharing and hopefully hand over to you, Alun.
Thank you, Tabitha. I'll just see if I can share my screen.
It's currently.
Hope you can see the slide there. Yeah.
Perfect.
Excellent. Thank you. Okay. Good evening, everybody. Thank you, Tabitha, and thank you, TDUK, for the opportunity to speak this evening. We're proud to sponsor the good work that you do. My name is Alun Watkins. I look after PEFC UK. I'm basically going to talk to you about the specification of wood, really. It's great that you've or will be using wood as a material. We have to make sure that we use good wood. So I'm going to give a little bit of introduction to PEFC and make sure that we get the specifications right for sustainable timber that's come from well-managed forests. Okay, just an introduction to PEFC. PEFC is the program for the endorsement of forest certification, and we're the largest forest certification system in the world at the moment. We're an international not-for-profit, non-governmental organisation established back in 1999 with a head office based in Geneva. The UK office is based in Sheffield in the north of England. So we promote sustainable forest management through independent third-party certification. We set the standards both for sustainable forest management and for chain of custody, but we rely on independent third-party certification bodies to do the auditing for us. That means we're one step removed from that audit process. Our standards, certainly initially when we started back in 1999, were very much focused on enabling smallholders, small woodland owners, family woodland owners to obtain certification and be able to put their material from their forests onto the marketplace with an eco label. And it's the eco labels that we use as far as the labels are concerned that do help people recognise products from sustainable sources. I guess in the construction industry, you're not going to see too many labels, but you might see someone on the pack wraps and that type of thing. Okay, so we're a two-part process really. The first one is actually the sustainable forest management, and the second is chain of custody. Both very much interlinked. We can't have one without the other. So we audit the forest to ensure that the forest is being managed in accordance with our requirements and in a sustainable manner. As soon as the product leaves the forest, enters into the supply chain entities have to have an independently certified chain of custody. So they'll all have an individual certificate to say that they can receive certified goods, put it through their processing, and sell certified goods. Everybody within the supply chain has to be certified. If one of the components of that supply chain isn't certified, then the chain has been broken and no longer can pass on those the certified credentials to the end user. So as a contractor at the end of the chain, we might be doing the construction. You have to make sure that the person you receive that timber from has chain of custody certification, and you need to do that checks and validation. And we'll check on that a little bit later. Very quickly, just to look at some of the benefits of sustainable forest management. I'm not going to go into too much detail here, as we have quite a few requirements that need to be complied with. Just to flag up really that when people think about sustainable forestry, they think about, yeah, we harvest trees and we replant trees. And it's as simple as that. Sometimes wish it was. There's a lot more to it. Obviously, we do replant. We do ensure that forests remain forests, but we ensure that the capacity to harvest timber from that forest is maintained and preferably enhanced. But we also look at things like biodiversity, not just with regard to the animals and plants, but I guess diversity as well as to the types of trees we're planting, the type of trees we need to plant for the future. Looking at climate change, we need to plant more resilient trees that are going to be around in 30, 40, 50 years' time. Carbon storage is obviously important, not just sequestering carbon during the growing phase, but obviously when it goes into products, the timber continues to store carbon as well. But in sustainable forest management, we also look at soil carbon as well. Water, people forget about how good forests can be as catchments for water supplies, turning water into fresh water, but also preventing flooding and the like if planted in the right place. Out of the forest, we get good products. We get renewable energy used in various formats, but it's the products that we're going to concentrate, obviously, this evening. But also look at the social issues as well, looking after local communities, looking after indigenous peoples where they occur, not in the UK, but certainly elsewhere in the world. And we can't forget the economic side of things, where we have over 40 million workers throughout the globe working in the forest products industry. Just a map of the globe to show where PEFC is present. 50 different countries now have endorsed national forest certification schemes under the PEFC umbrella. They're in the dark green areas. The light green areas are those countries actively working to have an endorsed forest management scheme in the not too distant future. The little blue dots are countries that have active chain of custodies with companies in those countries. At the moment, PEFC certifies something like 330 million hectares worldwide. There are two global certification schemes, PEFC and the other one being FSC. FSC at the moment certifies something like 220 million hectares worldwide. And between us, we account for about 13% of the world's forest. So again, between us, we have a long way to go, especially in the tropics, where the governance perhaps isn't as good as some of the temperate woodlands and the countries that have temperate woodlands. But we're working very hard to make sustainable forest management happen there as well. So as far as specifying timber, this is an example specification clause. It's very much an inclusive specification clause. And I think that's important because some things are predominantly available as PEFC certified, some things are predominantly available as FSC certified. And depending on which country you're buying from and what products you want, will depend on which scheme you probably buy your material from. At the moment, I would suggest if you're building in cross-laminated timber, most of CLT coming into the UK at the moment will be PEFC certified, mainly from Scandinavia or Austria and Germany. So the important parts of a specification like this is that includes both temporary and permanent works. Timber has to be legal and sustainable, and that's backed up by the UK government's Central Point of Expertise of Timber, or CPET. This was developed back in 2006. They've stopped doing assessments of the schemes now, but the policy is still in place, and this policy influenced a lot of architects, a lot of contractors in the way they set out their policies, procurement policies. So the chain of custody schemes recognised under CPET is PEFC, FSC, but also Grown in Britain. Grown in Britain is more of a provenance and legality scheme. So if you want to make sure that some of your timber comes from locally grown, then also ask for the timber to be not only certified, but also Grown in Britain certified as well. Some of the drivers, apart from contractors, builders, architects wanting to do the right thing by making sure the timber they buy is from sustainable sources, there's also the drivers such as some of the building certification schemes. These include BREEAM, the BRE Environment Management Assessment Program, LEED, which is an American-based scheme but is becoming more popular in the UK, and a SCAR rating one for refurbishments. While you're collecting points to be able to show off your sustainability of build through these schemes, if you're buying sustainable timber from PEFC or FSC, you're guaranteed certain points. So that's important. This is a boring slide. This is the slide about the standards that we have with chain of custody, rules around trademarks and sustainable forest management. There's also standards for certification body requirements and guidance. It does go on, but all these are available to download from our website if you wish. If you have trouble getting to sleep at night, they're very good for to help you with that. But yes, all downloadable for free from our website if you want to read through them. I'm briefly going to touch on chain of custody methods. And the reason for that is you will find that when you are specifying timber or when you're receiving timber, some of the timber will come through with what we call a percentage claim. Mostly it's 70% to 100% certified. It can be less, but the schemes such as BREEAM require a minimum of 70%. Three types of methods, I'm not going to go into them all, but just to flag up that companies who are processing timber can mix certified material with uncertified material during that process. To put a label on it and to meet some of those schemes, you have to have a minimum of 70% certified material in there. The other 30% has to be from what we call controlled sources. Those controlled sources are assessed through a due diligence system, which is in the chain of custody standard, and it's a mechanism to avoid material from controversial sources. Again, there's a definition of controversial sources in the chain of custody standard. So as long as the control source material meets those requirements, you can mix that with certified material to give you something like 70% certified material. The reason for that was certainly when certification was new 20 odd years ago, there was never enough material to go around for those companies who just required certified material. So we were allowed to mix a little bit. Ideally, in the future, 5–10 years time, percentage claims would have been removed. But just to make you aware of that, because you will see some claims on delivery notes, invoices, such as this. Generally, they will be X% PEFC certified, generally between 70 and 100%. A new claim of 100% PEFC origin is also available with our new standards, which came out in 2020. That means just direct from the forest with no mixing whatsoever. and control source material is something you might see, but very rarely in the UK. But the important things I think to take from this slide, two things you need to look out for: A, that there's a claim alongside the product description, and B, there is a certificate number from your supplier. That's really important. That shows that the supplier is certified. Through that number, you can go to our search engines and databases on the website and ensure that that certificate is still valid. People do lose their certificates sometimes, so it's always worth checking that they're valid, and also checking the scope of the certificate as well to make sure the materials that they're giving you is covered under the scope. Something else very quickly just to check, or just to point out to you, chain of custody is generally for the supply chain companies. There is something called project certification. So if you're using predominantly, for example, PEFC timber within your build, you can apply for project chain of custody, where the certification body will actually do an audit on the project, whatever it might be. Whether it be a house, block of flats, could just be elements of the building as well, such as a roof or a flooring, and give a certificate to that particular entity as a project certification, which can be used in promotion going forward with the client. So just something to look at. Labels, as I said, you won't really see too much of labels on a construction site, perhaps on some pack wraps around the timber maybe. But it's again worth looking out for when you're doing your weekly shop, possibly, to make sure some of the products that you buy come from sustainable sources. So these are the two labels we have: certified and recycled. Some examples where you might see them in DIY stores, builders merchants, timber merchants. And again on your weekly shop, more and more now on packaging. So just something to look out for. Before I finish, just some benefits of certification. I think the most important one is if you're specifying certified timber, that requirement goes, or request goes back through the supply chain, back to the forest owner, and we make sure then that more forests become certified. As I said, only 13% of the world's forests are certified at the moment. The more we can get people on the ground talking to foresters in various countries about sustainability and about what we need to do to become certified, the better. So the more we specify certified material, the better. It helps meet legality requirements, helps meet private and public sector procurement requirements. Very important, helps meet the customer expectations, and ensures traceability for the wood-based materials that you have. Obviously, with 50 national forest certification schemes globally, access to a large source of certified timber. But we also, by buying certified material, support the UN Sustainable Development Goals. Of the 17 goals, sustainable forestry probably plays a part in at least 9 of them. So I think that's a good plus as well. Further information, plenty of information on our website. If you go to pefc.co.uk, there are sections there on construction. There are PDFs of brochures that you can download. If you do want anything in hard copy, please let me know. I'll flag up my email address in a minute. But please look at those websites. A lot more information there, and videos as well about sustainable forest management. You can keep in touch or follow us through all these social media platforms. And my email address, if you want any further information, or if you want to look at the websites, one for PEFC UK, one for PEFC International. I think I might have done that in 15 minutes, which would be a record for me. Thank you very much.
Thanks so much, Alan. Can you stay online and put one thumb up for if you see the Sarah's video, and 2 thumbs up if you get the sound as well, because Sarah unfortunately can't be with us, and I need to share. She very kindly recorded. So let's see, we did have a go at this and it worked. So right, share screen to start with, sound optimizing, and then I just need to make sure that it
Hello, my name is Sarah Virgo and I am the campaign manager for Wood for Good. I apologise for not being able to be there tonight, not so much in person, but to do this, live. but I'm bringing this to you pre-recorded instead. Wood for Good is the UK timber industry's wood promotional campaign, and we are really pleased to be sponsoring and supporting this TDUK challenge for a second year. So a little bit of a brief background to who Wood for Good are. As I said, we're sponsoring the challenge again this year. We are a promotional campaign, and the primary purpose of Wood for Good is to promote the use of wood products in building and design to design and construction audiences. So we are slightly different to some of the other sponsors that you may have heard from or are going to hear from tonight, or have spoken to throughout this challenge. We aren't necessarily in the business of selling product or working technically with wood. We are a marketing organisation. Wood for Good was set up about 20 years ago as a promotional generic marketing campaign for wood products. It was co-founded by Confor and Swedish Wood, who are the UK and Swedish forestry bodies. Given the volume of wood that was imported into the UK, it is obviously within the interests of both the UK and Swedish forestry sectors to encourage greater use of wood in the UK. We are a not-for-profit, and we are financed very generously by the support of a range of organisations who you can kind of see on this slide here across the supply chain. We work with those planting the trees, to those processing them, harvesting those trees, and to those who sell and make those final products and sell those products to specifiers and architects and the general public themselves. Our messaging has always been focused on the aesthetic and environmental benefits of timber. We do talk a little bit about technical specification and about durability and offsite solutions, but we tend to very much stick to the aforementioned, environmental and aesthetic benefits. Our specialism is talking about why and how wood can be great for fighting climate change, how it's good for the environment, and how it's also good for us as occupants in the built environment. We have maintained our position as a timber industry's promotional campaign for over 20 years, and we have a really dedicated, loyal audience base, particularly within the architect and design areas, but also within the construction and forestry professional sector as well. So you'll have been given, an entire range of resources and technical advice, I'm sure, throughout this, webinar series. But as I mentioned, we don't really operate in that business of technical advice. But we do have, and what we can offer, and what I'd like to talk to you about tonight is the range of different information that we hold about wood and its role in reducing carbon emissions, its health and well-being properties, and its role in a circular economy. So our content holistically looks at that whole supply chain from seed to sawn products, which is, greatly helped by that wide supportive base. And we believe it is important for those in the built environment to have that understanding of where their product comes from, but it's also crucial for understanding wood's carbon storage benefits and properties. So I wanted to share some of that information with you and what we have on the website that might be useful to yourselves. So firstly, our life cycle database. It's a generic set of life cycle assessment data sets that we hold on a variety of timber products. It was developed with PE International and with Wood for Good supporters such as BSW and James Jones, who shared the data with us to create these EPDs. The data covers 4 different life cycle stages: production, transport, end of life, and benefits from beyond the system boundary, which essentially refers to the other uses for that product at the end of its life, including its ability to be recycled or used for biomass. We are actually due to update the EPD and all of this information later this year in April, well, later this year in a month's time, but the data is all still valid. And I know you'll have been given a variety of different other carbon calculator methods, and I'm sure you'll have been pointed to other data sets, but this is just an additional one that you can use as a resource for your work. So the data we have compiled is very generic, but it can be used as a base from which you can calculate or estimate the life cycle impact of your products and match the scope of the LCA that you need. So this data is intended to be used at the building or end of use product level, and it allows comparisons to be made between different options. So these are all of the different products that we currently cover in the EPD. As you'll see, there's sawn timber, engineered timber, panel products, and wooden windows. And in addition to the environmental data that we hold in the lifecycle database, which I should say you can find on Wood for Good's website, put a screenshot here. It's one of the key tabs on the website, and it's very simple and accessible and intuitive to use. But we also have an accompanying user guide, an FAQs area, and a glossary of terms on the website, which should help to maximize your experience using the LCA and hopefully make it easier for you to use that resource. But of course, you can use those resources alongside any of the other resources that you might use. We do think they're just a handy guide and good for breaking down potentially any difficult language or jargon. The other area of the website and the content that we hold that I wanted to point out to yourselves today was our case studies. It's one of the most popular areas of the website, and it is one of the areas that we excel at, I think, and that's bringing timber case studies from across the world to our audiences. Currently, we've got over 250 case studies on our website, and that's in a range of different applications and buildings, from windows and joinery and residential builds to mass timber offices, spaces and schools. So we've got something, hopefully, for everyone. The aim of the case studies is to inspire and motivate designers, specifiers, engineers, and to showcase the true potential of wood products in the built environment. We do have a focus on making sure that we've got lots of images and also having all that carbon information in our case studies. Obviously, that's something that we're trying to build on. It's not something that we maybe gathered, 3 or 5 years ago, but people are now doing those carbon calculations as part of their work and part of their write-up. So we're trying to capture that and put them all in the same place as well. I think it's really important that people have access to these numbers, and it helps to, inspire people who might be looking to build a more low carbon or sustainable building with timber. I wanted to share a couple of these case studies that we have that we thought might be relevant to the challenge and the spec that you have for this challenge. All of them specify timber, but for slightly different reasons. And it's also quite useful, I think, to see that it's not just the low carbon credentials of timber that are important to these designers and to these builders and to these clients, but there's other major benefits of building with timber as well. So I'd like to start with a community centre in Liverpool for squash. And after this presentation, you'll be able to access these case studies by clicking through on the PowerPoint slides as well, which I'm sure Tabitha will send around. But you can also always just search and find them on the website too. So Squash is this community space and cafe in Liverpool, and it's clad entirely in Scottish larch. Aim is to keep it a very welcoming space for this community hub of growers, of artists, environmentalists, beekeepers. Sustainability was a core, a core theme to their specifications. The project was situated on a piece of derelict land, and it was designed by Urbed, who are architects and a research consultancy. There was a real focus, as I say, on sustainability and reusing existing materials for the building, so that they could lower the environmental impact, not just in the embodied carbon of the timber being used, but also lower that environmental impact by building with less of the materials that they needed. And selecting the right materials is important, but also using less and trying to find ways to recycle and reuse as much as possible. So, for example, the insulation in the roof and the walls was made from recycled newspaper. There's recycled glass aggregate using the below floor insulation, and the building sports a recycled steel roof as well. The shop counters are made from leftover building materials, and the garden planters are also made from mesh fencing that was previously on the empty site. And the timber floor, to top it all off, is from reclaimed wood in an original school gym. So it's a really great example of people who have used timber, but not necessarily just for the low carbon credentials, but also for the fact that those materials that they sourced were recycled, reused, and having leaving less of a mark on the planet in that way as well. Next up is the David Bromlow Theatre. Again, a bit of a community space, but also primarily for the local school, but it's a community space for performing arts in the community as well. Designed by Jonathan Tuckey Design, the building is created from, it has a CLT structure and has been clad in red Virock. So the choice here of CLT was for two reasons. It was chosen for its cost effectiveness and the reduction of the amount of construction time on site, which is obviously important when you're building in an educational environment. And then secondly, it's for its low carbon credentials. So choosing CLT over the traditional block work, they estimated saved them about 40 tonnes in embodied carbon and operational carbon emissions over the lifetime of the project, which is a huge saving. And lastly, I've got the Abraham Darby Sports and Learning Community. So this brings together a primary school, an academy, and a community facility. And here the top priority was energy efficiency to help reduce costs, but also to embed sustainable credentials into the design of the facility as well. So this building has a whole mixture of timber materials. It's got glulam columns, it's got CLT panels, and it's got cedar cladding extensively throughout the building. So the carbon sequestered in the primary school structure alone is actually equivalent to about 2 years of CO2 emissions that the building would have used. And that's also what got it a BREEAM Excellent award as well. So, as I mentioned, obviously, there's a whole range of reasons why people might choose to specify wood as a core material in their projects, and I hope this gives you a little bit of a flavour of the other benefits of using wood, not just the reasoning for low carbon and sustainability benefits. But I also want to point you to some of the other useful areas on the website, in addition to the life cycle database and the case studies areas, that may help you just to build on that knowledge and information that you already have around using wood, and builds on some of these other reasons why people might specify timber. So as an organisation, we obviously represent the entire supply chain, and it's important to us that people who are using wood in the built environment also understand and know where that product is coming from and fully understand the sustainable commercial forestry model. So in 2020, we launched this campaign called Wood Costs Less, and basically it breaks down the low carbon story of wood into 6 key facts. And the great part about all of it is it's backed up with evidence and research capturing that entire supply chain life cycle. And you can read through these facts. I don't have loads of time, so I'm going to skim through. You can read through these facts on the website, and you can look at the research that's backed up each of those facts as well. And essentially, we tried to make it a really easy and accessible resource on how wood contributes to lowering CO2 emissions, but it is also helpful to have that evidence there, I think, to back up anything that you're writing when justifying using timber as a low carbon material. And secondly, I wanted to go through the health and well-being area of our website. So this is an area that we're also really passionate about promoting when it comes to wood, and that is the biophilic and health and well-being benefits of using wood in the built environment. So we've written a lot of articles, and we've interviewed a lot of experts on why and how timber in buildings can help to promote health and well-being. And this is just a snapshot of some of the content we've got on there and some of the kind of key figures and research, I guess, that relate to this topic. Some of these, for example, include, the fact that research shows that wood in homes helps reduce stress, it promotes connectivity and creativity, and it helps to lower blood pressure. The study that's usually cited is one from 2010, where in an Austrian school they compared a timber classroom to a standard classroom, and they found that children in the timber classroom had their heart rates lowered by up to 8,600 heartbeats over the day, really showing the power of a timber classroom and that exposure to wood for those occupants. So whilst it's fantastic to promote the low carbon benefits of using wood in your designs, but as a community project focused on people, I just think it's also important to mention that you might want to consider looking at why you would use timber, particularly for joinery and interiors, for the positive impact it might have on the occupants of the building too, in addition to its sustainable benefits as well. So you can find out a little bit more about all of these topics, obviously, on the Wood for Good website. We have a monthly newsletter where we share our latest, interviews or opinion pieces and case studies and other news. And social media is also somewhere that you'll find all of our content. Again, this will all be linked in the slides that you'll receive afterwards. Again, apologies that this is a pre-recorded session and I feel like I might have rushed through that a wee bit. I'm conscious I didn't want to take up more than 15 minutes. I would have loved to have been with you all, but unfortunately couldn't tonight. But I will answer any questions following this evening, and I've left my details here for anyone who wants to get in touch, but I can also follow up on anything if you email through to Tab before anything is said in the chat tonight.
Well, that's yeah, thanks to Sarah. That was a quick tour through Wood for Good's website and the amazing work they do. And yeah, as Sarah said, any questions, please send them through, and I'll make sure they go through to Sarah, and we'll get the answers for you. Next up, we have Janet Sycamore. So Janet, I'd like to give you the floor, or at least the screen.
Thank you, Tabitha.
Perfect, see, professional.
Cool, can see that. So hello everyone. We absolutely love this competition. It's such a great opportunity for you to put your learning into practice and work with people from different disciplines, and that's why we're really proud to be a sponsor. So today I'm just going to talk about timber cladding, because you're not being asked to do any landscaping, so decking probably won't be involved. Maybe? Okay, well, I'm just focusing on cladding for this evening anyway. And I'm hoping that you'll be using timber cladding in your designs. I'm going to give a brief run through some of the key aspects that you need to be aware of, because 15 minutes is not a great deal of time to cover this subject, so I'm going to focus on some of the fundamental key things that you need to know. So, quick introduction to the team first. So we've got Steve Young. He oversees everything. He's been with us since year dot, since the beginning. And then we've got Barbara, myself and Caroline in the office. Got Nick in the field doing audits and inspections. And then we've got Dr. Ivor Davis, who's the one I really want to mention, because he is our technical support guru. I mean, if I can't answer a question on cladding, he certainly can. And it's great that we've got him as backup for the more complicated queries that we get. So the Timber Decking and Cladding Association is a not-for-profit technical advisory body, and we're supporting the timber decking and timber cladding industries. We're funded by our members, and the membership is made up of like-minded, quality-conscious companies who basically put their money where their mouth is and stand up for quality, good quality. So there's our principal objective on the slide. You can read that for yourself. And our basic message is to specify correctly, install following good guidance recommendations, and maintain as advised, and you will get a long-lasting, high-performance product. So these are the go-to references that, that we refer to. BS 8605 Part 1 is a British standard. That's a really good standard, but that would cost you about £268. So what we've done is summarise some of that guidance in a timber cladding handbook, which we put together with the Timber Trade Federation, or TDUK as it's becoming. So, and that's supported by the Wood Protection Association and Wood Campus. And you'll get a copy of this, you'll get access to it, a digital version, and that's going to be really useful because it provides very clear, illustrative, relevant information on material design, material choice, design and installation. And it's aimed at specifiers, designers. It's also good for the end user or the client if they want to kind of check that what they're getting is what they should be getting. It's quite handy in that respect. The other publication from TDUK is the External Timber Manual. It's actually in its 3rd edition at the moment, and the 4th edition is almost there. And that's going to be brilliant when that document's available. It's not quite there yet, but that's written by Dr. Ivor Davies. So looking at your material choices then, you've got broadly 3 categories of materials. You've got naturally durable species, you've got those that aren't durable that can be enhanced with a wood preservative, and you've got modified timber, which is timber that's been physically modified in a process that changes its properties to enhance durability. So within the durability category, all species are given a durability class. There's lots of these class ratings and they can get confusing, but bear with us. So class 1 is very durable, class 2 is durable, and class 3 is moderately durable. And if you use these species, you can get an indication of what the service life will be, which I've given you there as 60, 30 or 15 years. And these ratings refer to the heartwood, which is the core of the wood here, and the sapwood of all species is not durable. So if you're using durable species, you would limit the sapwood to the face behind, but not on the exposed. You can tolerate a small amount of sapwood, but it has to be on the behind the face, back face. Preservative treated as generally softwoods, and that is upgraded in a timber impregnation process in the factory, and you would specify to a use class 3 end use specification. So this is another class system that is used for wood preservation, and it categorizes everything into different classes. So use class 3 relates to external above ground, where it's subject to frequent wetting, and this would apply to both the cladding boards and the battens upon which they're fixed. So that means that roofing battens used behind cladding are not appropriate because they're use class 2. So you need bespoke cladding battens when you're fixing cladding to a building. So with preservative treated timber, you can have, well, the default service life is 30 years, or you can have a higher one by bespoke order. And similarly for modified timber, you've got a couple of service life options, 30 and 60, and some suppliers give warranties on the products. So here are some examples of different species that can be used. The softwoods are in brown, so you've got non-durable softwoods that are treated like spruce, and then you've got durable softwoods like Western red cedar. You can have the Canadian variants or homegrown. And there are some hardwood examples there, Kumaru, Garappa and Iroko, and with the different durability classes that are associated with them. And then in green at the bottom, there are examples of modified wood species. So there you've got a Bodo and Accoya, which both use radiata pine from New Zealand as the base material. And also when you modify timber, you can get, as well as getting improvements in durability. You can also get improved dimensional stability. So as you can see, there's a movement class column there. So all species are assigned to a movement class, and you would detail slightly differently the material depending on if it's small or medium. And you'll see that Accoya is unique there with its very small movement category, because that really does have good dimensional stability. So the key considerations that I want to tell you about, this diagram here on the right is courtesy of Ivor. It's his diagram, and it shows the functional layers in the building from the internal through to the external layers. And you'll see, as you'd expect, cladding sits there in the external outer part of the building, and behind it is a cavity which is drained and ventilated. It's ventilated top and bottom, and then that's fitted over a breather layer which protects the internal building layers from moisture. So the cladding and the battens are in the wet zone of the building. Timber, when it gets wet, it moves slightly, so we need to accommodate for the natural movement of the timber within the design. So that means taking note of movement gaps and overlaps and things like that, dimension restrictions. Install at 16 to 14% moisture content. That's roughly the middle of the road, the in-use moisture content, so that's going to help. As I said, cladding is fitted over a batten arrangement over a drained and ventilated cavity, and the ventilation's top and bottom. So that's critical. When the cladding's in vertical orientation, it requires the use of a counter batten to create that drained continuous cavity. The batten size generally dictates the depth of the cavity. You could get away with a much smaller cavity, but you need a batten about 38mm thick, depending on the orientation of the cladding board. And so that's going to dictate the depth of the cavity. Fit metal vermin mesh at the base to protect against vermin, and then minimise the risk of flame spread with cavity barriers. So intumescent strips between floors horizontally. You can use 38mm thick timber vertically at window frames and doorways. That's a very quick run through some of the key things, not all of them. So the one I just missed out there was use appropriate fixings designed for exterior cladding. And now every time we do an inspection, there's 9 times out of 10 there's a problem with the fixings. And we had this one in yesterday, which is a superb example as to why you should use appropriate fixings for the cladding, because this beautiful Western red cedar cladding has been fitted with used the wrong fixings there, and you've got interaction with the acids in the timber, which has resulted in these dark streaks, which is essentially iron staining because the fixings aren't rust resistant enough. And it's very sad, and we do see things like that too often. This table shows you the different profile styles and how they can be used, and as this is covered in BS 8605. There's 5 different profile styles there: tongue and groove, rectangular board on board, feather edge, shiplap, and parallelogram. So I'll just mention tongue and groove because that's quite a popular choice. And we have a width restriction on that, which is 125mm, unless you're using something like Accoya. You could go a bit wider than that. And then obviously it's very versatile because you can use it in horizontal, vertical and diagonal arrangements, so you've got a lot of options with that. And generally, with regard to board width and thickness, the general guidance is 4 to 6 times. The width is 4 to 6 times board thickness, unless you've got a very small movement species like Accoya. You can change that, or you can go lower but realise that that's going to impact on your costs. And then this table, also from the handbook, tells you about the different movement gaps you require for different board widths, and it's for tongue and groove and shiplap in terms of the movement gap. So this little gap here, that's the movement gap, and you can see it ranges from 2 to 4 millimeters depending on the board width for a small movement species. And then you've also got guidance on tongue width and tongue thickness, and again we do see a few issues where people have used essentially a board that's designed for interior use and not exterior use, and the tongue width is just not big enough. So it's something to be aware of. And then here, these little diagrams just showing you that the best orientation is with the pith of the wood facing outwards, because then if you get a bit of cupping, it's cupping into the building rather than cupping away from the building. So now I'm just going to show you some examples, really to show some different materials and different visual styles essentially. And they're all from our members, and they're all pictures taken from the cladding handbook that you'll get access to. So we've got this is rather nice. On the left, silver timber, western red cedar in vertical orientation. And again, the one on the right is another silver timber one. It's quite apt that they used cedar for the clubhouse at the Cedar Club. And then in the middle, we've got British larch, and that's a shiplap board. We've got a hardwood on the left here, on a cylindrical building. Goes without saying that curves are best achieved with a vertical board on board orientation. It's pretty difficult to do circles with a horizontal board. And the one on the right is, that's Kumaru, by the way, and the one on the right is an example of a coated horizontal board from Haworth Timber. Then into the modified species, this one on the left is a Bodo from Glenarmon Timber, and then an example of coated Accoya in horizontal orientation on the right. And you're going to learn a lot more shortly with Mike, who comes on after me, presents after me here. So that's from Axis. Charred Accoya on the left, which gives you a nice, almost black colour. So it's a nice look. Some people will claim that gives you added durability. It doesn't. It's a surface layer. It's an aesthetic. It's not going to add to the durability. And then the one on the right is a product called Aero, and that's gone through all sorts of processing. It's homegrown larch as the base species, charred, brushed, treated, kilned, and finished with a colour, factory applied colour application, and that comes in a range of colours. And then the weird and wonderful. So the one on the left there is an Accoya, rather strange orientation. Western red cedar up there, and then this is from Haworth, it's Fraquet. So that's as much as I want to say. This link at the end of the presentation takes you through to the website where you find more information. If you have any questions as you go through the process, don't hesitate to contact us. Contact us through the contact us form on the website. Tell us you're part of this competition, and we'll prioritise your inquiry and give you a speedy response. And of course, if it's a complicated one, it'll be from Ivor, not me. So thank you for listening, and I'll welcome any questions.
Thank you, Janet. Absolutely brilliant. And thank you for the offer. And yes, it's my fault for not saying it. There's no way would you have got decking in as well. So there is an opportunity to have an inside outside space. So I think decking, you know, especially with a more of a veranda around it. Okay. So I think we'll try and find you some time to come back and maybe talk about
it's similar principles, well ventilated, well drained, will add to the longevity. And the similar kinds of species are used because you want to select species for durability. So pretty simple.
And the use class for the joists and any posts.
absolutely.
Yeah, that's good. I was in a talking to university students the other day, and one of them surprised me by specifying his post as UClass 4. And I was just utterly amazed. It was just brilliant to see.
Yeah.
So yeah, the message is getting out there.
Yeah.
Thank you, Janet. And Mike, can I welcome you to the webinar and to talk all about Accoya?
Yeah, of course you can, Tab. And Janet, that was really good. And you said all the right things about Accoya. That was fantastic. And you put some nice pictures up too. So I'm Mike Lewis, and I work for Axis Technologies, and we are the manufacturers of Accoya. So Axis Technologies. So we are the company behind the acetylated wood brands of Accoya and Tricoya. Accoya is the solid wood version of acetylated wood, and Tricoya is acetylated wood chips that's turned into a sheet material that's marketed in the UK and Ireland as Medite Tricoya Extreme. So Axis, where did we start? Where did we come from? We kind of grew out of a research project that was initiated in the Netherlands in the late 1980s, although we are now a UK company. And our expertise is in the transforming of regular wood into a modified wood through the proprietary wood acetylation system. So at the moment, we only have one factory that's based in the Netherlands. We have a factory which is about to be commissioned in Hull, which will be producing wood chips for the Tricoya panels. And we are in advanced discussions with other consortiums around the world to build other factories outside of Europe. So by significantly changing the characteristics and properties of regular wood, we're giving architects and specifiers more confidence in using it for buildings, and perhaps using Accoya where they would ordinarily use plastics or aluminium or concrete or other materials, carbon intensive materials. So the more Accoya and the more wood that is used in the construction industry, the less of an impact it has on our environment. And because we're changing wood and we're changing where the construction industry uses it, we like to say we're changing wood to change the world. So that's who we are. So, in fact, I've done that. So, what is Accoya? What is the Accoya process? Well, really, it's the acetylation process. Acetylation is it's chemistry that modifies wood. So, without going into kind of a big timber technology thing, wood is hygroscopic. That means it always wants to find a moisture balance with the surrounding conditions. Take a piece of wood and put it somewhere damp, it draws water because the wood wants to be as damp as the environment around it. And when it does draw water and water bonds with it, that piece of wood swells. Similarly, take a piece of wood and put it somewhere dry, the reverse happens. The wood releases water because it wants to be as dry as the environment around it, and it contracts. And this is where the problems start in wood. It moves around, and we can't always be certain of its behavior. Well, the driving forces behind this process in regular timber happens at its molecular level. There's a bunch of molecules down there called 3-hydroxyls, and it's those 3-hydroxyl molecules that want to find a moisture balance. And when water bonds onto them, those molecules get slightly bigger, causing the whole structure of wood to get bigger, and the piece of wood expands. And the reverse happens when those 3-hydroxyls release water. Also in wood, there's a smaller amount of what are called acetyl groups. And acetyl groups are more or less inert to water. So in summary, there's a whole bunch of water-loving molecules called hydroxyls and a small amount of non-water-loving molecules called acetyls. In the process of acetylation, we reverse the balance. We turn all of the most of the hydroxyls into acetyls, just leaving a few left. So this change of balance means that we're taking away the wood's ability to want to bond with water. And all we've done is just change what's already within the wood. We haven't introduced anything new. It is a chemical process, but the chemical that we use to modify the wood is acetic anhydride, which is basically concentrated vinegar, now, or acetic acid. Now, acetic acid is a chemical that's found in all wood. So we're using a naturally occurring chemical that's already within the wood to induce a molecular reaction in the wood, and then we take it all out again, or certainly take most of it away again. And the acetic acid that we have used in the process, we either recycle or sell. So it's not a one-use chemical. So some of it we sell into the pharmaceutical industry where they make paracetamols and aspirins and so on. We sell it into the clothing industry, and it is the same strain of acetic acid you might find in a jar of pickled onions. So if you're sprinkling vinegar on your chips and you get a few splinters, maybe that's where, maybe it's our vinegar. So it's completely non-toxic, and the wood is it's friendly. If it, it's friendly for biodegradability. It can be used for wood pellets. It can be used for biofuel. It can be used for animal bedding. So there's nothing nasty about the wood. So acetylation is changing the balance of the wood. But the other benefit of this change, not only does the wood become the most stable wood that there is, it also becomes the most rot resistant, because it's the same 3 hydroxyl molecules that rots and fungi, ants, insects, or anything else that wants to eat wood, that's their prime source of food. And because we've changed the hydroxyls into something else, we've effectively taken out of the wood or modified within it the food source for anything that wants to eat it. So Accoya can't go rotten because there's nothing to eat. There's no food value or nutrition in it at all. So acetylation renders regular wood to be the most stable and to be the most rot resistant that there is. How do we know it works? Well, there's been all of the leading wood institutes around the world. They like to study, they like to research Accoya. And there's a couple of examples here in the top picture where we see the end on bits of wood. This is some work carried out by TRADA, trying to see how different woods cup. So they did an extensive research program. They took some photographs. So at the top we can see P, which is pine, that's cupped. The next one is Accoya, Siberian larch. These are all commonly used woods for cladding boards. The larch, that's distorted quite a bit. Cedar, that's a fairly stable wood, but it's gone a bit. Then we have Euro larch, and then we have thermally modified wood, which is another modification process, and that's gone slightly. So despite the best efforts, TRADA couldn't get Accoya to distort. There's also been lots of durability testing carried out, throughout the years. In the graph at the bottom, this is called a state test, and basically bits of wood are put into the ground, and then every year an assessor comes along and marks the wood out of 10 for degrade. 10 being the best, it hasn't started to go rotten, 1 being it's not doing too good. And then if you look at the graph on the horizontal axis, that's the amount of years that the test has been going on. So Accoya, that's the green line at the top, it has been slightly downgraded, but that's because it changed colour, nothing else. But in the same test, quite interestingly, there's genuine Burmese teak. That's the red line. So Accoya has been demonstrated to be more rot resistant than genuine Burmese teak. So we as a business, we offer a 50-year warranty on Accoya above ground for the first signs of degrade or rot. That's with or without coatings or further treatments. If Accoya is buried in the ground, we'll offer a 25-year warranty. In fact, this is the first time I've seen this slide, and I can see that it was used for canal linings. But that's actually incorrect. It was used for canal linings 25 years ago, not 15 years ago. And we did take a board out. These are big chunky boards. We wanted to see how the wood's performing. We put those boards in place when we were an R&D business. We skimmed the surface, took a mil or so off, and the wood was perfect. Absolutely nothing had happened, 1 millimetre down. So although we give a 25-year warranty at ground levelling in the water, maybe that's being a little bit conservative. It has a 60-year service life, according to BS 8417. because it is class 1 durability. Now, interestingly, every single piece of Accoya is class 1 durability. There may well be other timbers which are class 1, but depending on the rate of growth and the density of the tree, then maybe some boards aren't. So yeah, it's the most rot resistant wood that there is, pretty much. Another benefit of the stability side of things is that Accoya significantly prolongs the life of paint. Now, that's a bold statement, but on the bottom picture, you can see those 4 boards. This is an actual test that quantifies that and validates it. This was carried out by the Dutch Wood Institute. They're called SHR. And in this test, they got 2 bits of Accoya, which are the 2 left-hand panels, and 2 bits of regular softwood. In this case, it was Scots pine. And they painted all 4 panels at the same time using the same water-based paint. And then they put them out onto a test rig and just left them for 10 years. They actually forgot about them, but after 10 years, brought them back inside and took these pictures and noticed a difference in the coating's behaviour on the Accoya compared to the Scots pine. And it's quite a significant difference. And the reason for this difference is that the Scots pine is shrinking and swelling, which is putting stress on the coating. But more importantly, it's the grain, it's the surface of the wood that's going up and down all of the time. And all of that movement just throws off paint. Paint doesn't just decide to fall off one day. It's what's going on underneath the paint that throws it off. In the case of the Accoya, it's not shrinking or swelling, and the wood is as smooth as white plastic. So there's nothing going on to throw off the paint, so paint lasts longer. So all of the world's leading coatings companies get this, and they all extend their warranty if they know Accoya is a substrate. And the likelihood is, if a piece of Accoya, whether it be window cladding, whatever, is coated with a film-forming coating, the likelihood is it won't need to be redecorated for 10, 12, if not many more years. And when it does come to redecoration, well, you can imagine sorting out the Scots pine panels, sanding and filling, but in the case of Accoya, it's literally just wipe it with a damp cloth and just paint it, easy. So on the top picture, that's Carradale House, that's in Tower Hamlets. It's a listed building, a real good example of brutalist architecture designed by Erno Goldfinger, actually of James Bond fame. So they because it was a listed building, they wanted to use wood at height. It could be a problem, maintenance going forward, but they chose Accoya, and it was coated with a Technos coating, and that was maybe 10 years ago now, and the wood is looking absolutely fine. So this is a great example of how Accoya not only enables products to remain looking pristine and tidy, but it also significantly extends maintenance regimes, and the actual maintenance is much simplified. So Accoya, it's pine, but it can have different effects. So on the left, that's got a translucent coating. In the middle, that's being charred and brushed, and it's had a surface finish on. And over the right-hand side, that's just a sawn board. It's been sawn with a bandsaw, hence the vertical lines, and just left to silver and weather. Many different tones and finishes and effects and brushing effects can be achieved with Accoya. It is versatile in many ways, like other types of wood. So how does Accoya benefit the planet? Well, the wood started life as radiata pine, which is grown in New Zealand, which is a very fast-growing timber. Now, these trees hit 30 meters in 28 years, and that's when we harvest them. So these trees are growing a meter a year. So because they are growing at such a fast rate, they are sequestering or absorbing carbon at a very fast rate. We then come along, fell the trees, modify the wood, and turn the wood into something that doesn't degrade and go rotting. So we are therefore trapping carbon into finished planks of wood. Rotting wood returns back to carbon gas, but because Accoya doesn't go rotting, we're trapping the carbon in the finished planks. So an Accoya plank is basically a lump of greenhouse gas. Another benefit of Accoya, with it being lightweight and not containing a great deal of water, it's much more thermally insulative than other types of wood. In fact, its lambda value is about 30% better than hardwood, and it is slightly better than softwood too. So yeah, if windows are made from Accoya, we've got much better insulation values and lower energy bills, which is quite a topic at the moment. Cradle to Cradle, an American organisation, they look at many different aspects of different products. Now they're looking at material health, recycling, renewable energy, carbon management, water management, all sorts of things. They're looking at embodied energy and carbon consumption in the production of materials. In the case of Accoya, Cradle to Cradle have awarded Accoya an overall gold certificate across all the many categories. But in the one category of material health, Accoya has been given the rarity almost of a platinum certificate or assessment. And of course, Accoya is recognised by organisations, and it contributes to green building schemes such as LEED and BREEAM. EPDs, they're all in place for Accoya wood itself and for products made from Accoya. So all of these are accessible to you from our website and elsewhere. So moving on quickly, so where does Accoya get used? Well, all sorts of things: windows, doors, cladding, decking, garden furniture, pretty much everywhere where you want to use wood, but you don't want it to move around and look unsightly, and you don't want it to go rotten. So this is a project. It's they call it Wood City. It's in Finland, and Accoya was used for many of these buildings' facades. In fact, around about 420 cubic meters of wood has been used so far, and most of it has been fire treated to Euro Class B. So in the wood that's being used for these facades, it's been calculated that there's been 337 tons of CO2 has been locked into the wood used on the buildings. And this is an ongoing project. They like wood in Finland, quite rightly so. So there's going to be many more buildings and many more of them containing Accoya. This is a project in the UK, in Wiltshire, Dyson, the vacuum cleaners. So this is kind of their student accommodation buildings. And they used Accoya for the sliding doors on the front of these buildings. Nice project, 30 tons of CO2 has been locked in to the wood that's being used for these buildings. And the architect, if you're interested, is a company called Wilkinson Air. My daughter worked for them for 1 year, and the window and the doors themselves were made by Treecraft Joinery up in Scotland. So yeah, nice example of where Accoya is used for doors. This is one of the very first projects where Accoya was used. It says it's 12 years on, but I think it's actually 14 years on. So this is Deal Hospital in Kent, and they chose Accoya for the windows, and the windows have not yet been maintained. In fact, I don't think they've ever been cleaned. So when we took some recent photographs, we could, if you look at the bottom, we can see that the paintwork and the wood is in wonderful order, apart from the windows are a little bit dirty. Now, if these windows were cleaned, they would look brand new. After 14 years, no maintenance required yet. This is a project, this is near to where I live actually, in Ashby de la Zouch. So round about 6 years ago, 5 years ago, they built the Marks and Spencer's building, and they used Accoya for the brise soleil, the beams, the columns around the building. A few years later, right next door to it, they built another building. It's a B&M store using exactly the same specification of Accoya columns around the building. And I went here not so long ago. I just wanted to see the difference between the two. And with regard to how the coatings are performing, how the wood is performing, has there been any coatings failures or anything? And there was not a scratch of difference. Magnificent. And in fact, the Marks and Spencer's one, which is the older of the two buildings, the wood, it looked like it had been supplied yesterday. So marvelous. So when we talk about coatings lasting longer and things looking better for longer, these are prime examples. And it's actually quite nice to see two entirely different brands using exactly the same, high-end Accoya. Really nice. So yeah, that's it. So that's a quick 15-minute insight or oversight into Accoya and acetylated wood. And if you do want to find out a little bit more, I and my colleagues, we will be at Future Build tomorrow. So thank you very much indeed for your time. And yeah, I hope you found some of that interesting.
Thank you so much, Mike. I learned new information again, really good. And I love the continuation between the speakers and the projects coming on. And watch out with Mila's, because there will be another building coming up that you're both highlighting. Yeah, no, thank you so much. There are some questions in the chat, and Alice, I think you sent one, but you sent it to me directly. So you want to either pop it in to everybody or directly to Mike. And Mila, the floor is yours.
Awesome. Thanks so much for inviting me to the floor, and I've really enjoyed the talk so far. So yeah, difficult to follow up from all the fantastic speakers, but I shall do my best. So I'll start sharing the screen, and any issues, just interrupt me. Happy to have a conversation. Thanks, Tab.
All good.
So, yeah. Oh, good. Amazing. Thank you. So yeah, I'm Dr. Mila Duncheva. I'm the UK Business Development Manager within Stora Enso Building Solutions. And I'm going to start off with a little bit about the company. You may not know, but we're actually the oldest limited company in the world. So we've been operating ever since the 13th century. And in that time, we've moved to being Europe's largest timber supplier, and we're number 4 globally, which is quite important. And we're one of the world's largest mass timber suppliers as well. But that is only one piece of the puzzle in terms of COT, the topic I'm here to speak with you about. You should really be aware that everything we do in the business is about trees and how can we add the most value to trees. So naturally, that starts off with managing our forests in a sustainable way, being one of the biggest forest owners globally. That's very important to us. But we also manufacture paper and packaging materials from the trees, and quite interestingly, we're working on some fancy biomaterials right now in R&D, such as looking at can we replace the metal in airplanes with wood-based materials. So yeah, I'm quite jealous of my colleagues who get to have fun with that. And I am in wood products, and we're all about building components. So within wood products, we do have 2 key building systems, building products that you can choose from, cross-laminated timber and laminated veneer lumber. And these come in various shapes and forms. They can be, as you can see, they can come in as sheet material to be used in floors or walls. They can come as rib panels, which can help you achieve bigger spans in the floors. You can have pre-CNC'd staircases. Indeed, you can have a post and beam system as well. So there's quite a lot of variety there to choose from to achieve your desired vision. Now, in addition to manufacturing the products, we also add a lot of value to them in the factory. For example, we have coatings that help to protect from moisture, from UV radiation, termites and insects, if that's relevant in the context, which I think is not for this challenge, but in general across the world is. And you can pre-fit lifting devices or even brackets, and all that helps with those marginal gains on site when it comes to productivity and efficiency. So the components themselves can be used in 2D form when they're stored component by component on the building site, and are then finished traditionally by sequencing trades on site. So you have your internal finishing trades and your external finishing trades coming in to do the cladding, etc. Or another great option is to use COT and LVL in a factory environment, in which case you can make pre-manufactured modules. Here we have an example. Modular or volumetric is how people refer to the system, and you can achieve pre-manufactured values of about 80%. What does that mean in practice? The modules come in with light bulbs pre-fitted, with kitchen cabinets pre-fitted. You just connect it to the mains, join them together, and you're good to go. But that's not the only way in which the products can be used. This is quite an interesting example, more of an art piece. So this is a topography of a water feature, and I know that near your site you've got a water feature as well. So is there a link there of showcasing that and its important heritage within the timber material? Because one of its key benefits is that you can CNC, you can mill it, however you wish. And you can use it in different, click from there. So yeah, that doesn't necessarily mean that you always need to create enclosed spaces fully as well. I know that for your brief, you may want to consider some indoor-outdoor spaces. So this case study is actually a student project, and as you can see, creates a flexible, this could be a learning space, for NMITE, it could be for growing local to have a class, it could be for the footballers to have a coaching session, because you can see the possibilities are endless. Or you can go a little bit fancier in terms of design. So again, this is another indoor-outdoor space which combines terraces with steps and then an enclosed cafe area, so that you can be protected from the elements when needed, but then you can also go outside and enjoy the great outdoors in the Queen Elizabeth Park. And this is all achieved with a post and beam system, as you can see here. In terms of education, because I know that's a big part of your brief, so we're very proud to be providing the COT for the NMITE building, the Center for Advanced Timber Technology, and we're using it as a bit of a test bed, as Robert, I'm sure, has already said. So we're measuring the moisture on site to get some data on that moisture and durability from a long-term view. So that's one educational building, but that doesn't necessarily mean that's the only shape and form in which educational buildings can be designed. This is an example of a relatively larger auditorium, as you can see it here during construction, and you can achieve these amazing, acoustically beneficial spaces. Thinking of your brief, I'm wondering, can you actually make a big hangar similar to this and then house all the different activities within it in a type of pod system? So a big open space can be quite flexible in that regard. Or you may want to go for a purely utilitarian approach, which can include, passive house design, such as this passive house kindergarten, with just the really gorgeous exposed mass timber spaces on the inside. Because I know that the Passive House Institute are a big part of this challenge. So just to emphasize, COT is highly beneficial when going for passive house standards. Now, again, thinking about some case studies in preparation for this, I was thinking that actually kindergartens or school buildings combine a lot of the uses which you already have in your brief. So let's say this building, it has an educational purpose because it's a school. It has a sports purpose because it has the sports center, but it also has some outdoor spaces. So, very similar in terms of function of all the activities you are summarizing within your buildings. And that's not the only one. This is a UK project from up north in Aberdeen. And as you can see, again, it manages to house those different functions very efficiently with quite a different aesthetic. This one shows the opportunities to use mass timber elements going both from the outdoors straight to the indoors, which can be very useful in a sports environment. This is again, similar in function leisure center, which combines a cafe area with sports and some outdoor activities as well. Thinking about the accommodation for footballers, etc. Big nod to everybody who's involved in the Dyson Village project, including Edinburgh Napier, who did some fantastic research, and we were very happy to supply the COT. But my logic here was, you see, you got some changing rooms for the football team. So could you actually think of those as mini residential units in a pod style scenario, and achieve them using volumetric systems? Or if you wish, again, you can take that residential concept and apply it to those rooms using the passive house standards. Now, I'm here to talk more about useful tools which you can use. And in this case, I'll talk you through some of them. We do have tools which are applicable from the planning through the building all the way to the life in use part of buildings. You can see some of them here, and I will highlight a few such as the BIM library and Calculatis, but that is not all. As you can see, we've got quite a few options there. And if you're wondering, okay, so you've got COT, you've got LVO, what do I actually do with it to turn it into a building? We've got some tools there to help you as well. We've got our building concepts, which talk you through how do you go from product through components and application to achieving a vision in a preset conceptual parametric type design options for you. And of those, I think the school concept will be quite relevant for the reasons already mentioned. And if you're looking for anything that's a little bit more technical, such as EPDs or ETAs, anything that you need to quantify your project so that you can present a more compelling science-based or evidence-based pitch to the juries at the end, then our download center would be your best friend. And finally, if there's anything you can find in any of those links, then you can go straight to the Stora Enso Wood product site, and that will lead you to other parts. Now, there's been a whistle-stop tour because I wanted to actually show you how these work in practice. Just to check, Tabitha, can you nod if you see the website instead of the presentations? Yeah. That's all good. Awesome, great. So this is what some of the links I spoke about look like. This is our digital tools webpage where you can find Calculatis as well as the BIM toolbox, and our reference library is an amazing resource if you want to find a little bit more information about any of the projects I just highlighted. Our ProdLib library or the BIM library is available to be downloaded. It can be used either as a Revit plugin or as a SketchUp plugin, or indeed it works with most of the design softwares as a plugin. And what's that been designed for is to actually help you as a designer to model your building very quickly and very accurately. So you can see an example here. I've got a COT panel spanning lengthwise, and within the Revit or SketchUp or the type of viewer, what I can do is I can select my master panel size, which impacts transportation in terms of width. I can also go into the level of detail thinking about what's the width of that COT panel and also how many layers do I need it to be made out of. And as soon as I choose those are that the more objects have information within your modeling environment to save you that time and really create a rapid design process. But to know what type of COT, LVO, or glulam or other panel and connector you'd need to use, you'd also need to do some calculations. And that is where our Calculatis tool comes in. So this, similar to the ProdLib library, is absolutely free to use. All you need to do is register, and then you get an automated email with confirming it, so you don't need to wait for a human to send you an email, which is quite quick. And what it does, it's surprisingly powerful, actually. So you can do your screws and your plates and all that specification, which is kind of the first point of call. But you can also design floors and walls, beams, columns, and quite importantly, I think for me in terms of performance, you can design your fire performance, engineer that. You can engineer for hygrothermal performance, such as U values and dew points, etc. So it is a really powerful tool, both for technologists and for engineers. And you do need to be a little bit engineering minded to use it, but that doesn't mean you need an engineering qualification. So please feel free to have a go. And a concept navigator really brings everything else together. So within this, you can take inspiration to create different types of buildings. And you can see here the list is endless. And what's quite important is that they all come with a life cycle assessment as well as a cost study. So you can get some estimates there in terms of carbon, but also in terms of cost, both of which I know are important to your brief. And finally, this is what our brochures and download center looks like for COT. Got the brochures there, which are the nicest looking graphics. but the best part of the science or the evidence you can really see here in DPD's PEFC certification, of course, thank you, Alun, and many other aspects. So yeah, that's me. I hope you've enjoyed the presentation, and my contact details are in the slides if you want to get in touch with any questions. Thanks so much for this opportunity, and all the best with your designs.
Thank you so much, Mila. I see Utter Professional linking to PEFC and obviously the Dyson projects, which yeah, it seems to go across all of them. And as I said, I love the continuity. I know we're just running a little bit over. I'm going to take questions in a minute. I just want to say a huge thank you to our speakers tonight, and they're very, I said, we could not put this challenge on without them, and I know they have all sponsored us since we've been running challenges since 2018, and it's so heartening to see the value that they get from it, but the knowledge that they transfer to you. So Alun, Sarah, Janet, Mike and Mila, thank you so much for educating our future professionals. I'd like to invite you all to join us on Thursday, when I thought it was titled Bringing Timber into the Digital Age, and somehow it's ended up being translated into Bringing Timber into or onto the digital stage. So whichever one you want to take it for, we're going to talk about obviously the use of digitization and how it relates to timber. We'll have Gary Newman from Wood Knowledge Wales, Luke Whale from Staircraft, Jamie Johnson from Bryden Wood, and Mila will be returning with her new boss, Gareth at Stora Enso. And I know there was a question in the chat about where does the timber come from? So I know Mila's going to talk about that on Thursday. So thank you for lining that up really nicely. And so this is Timber Development UK, the Southside Hereford University Design Challenge 2022. We still have a few spaces left for students if you want to join us within the teams. And yeah, we're going to be getting underway very, very shortly. Bear with me a minute. And I want to say good night.